we're going to look at a problem where we're given a region R, okay, and we're given two graphs. The first graph is radical x. Obviously, radical x is a half a parabola, so that's going to be our radical x. And then our next graph is e to the negative 3x. Since it is exponential decay, it's got to be this one, okay? And I found their intersection points on the graphing calculator to be this value. So the x value here is 0.238. The first part of the question is asking us to find the area of R. Easy enough, so all I'm going to do to find the area of R is I'm going to do top minus bottom, and I'm going to integrate the rectangles as we go across. So it's going to be the integral from 0.238 to 1, and the top function is the radical x. The bottom function is the e to the minus 3x dx. This is a calculator portion, so I'm going to plug it in the calculator. And the calculator says that this area is approximately equal to 0.443. Okay, it doesn't ask for units, so I'm not going to give it any units. Next part of the question says find the volume of the solid generated when R is revolved around the horizontal line y equal to 1. Y equal to 1 happens to be here. So what we're going to do is we're going to take the shape and revolve it around there, and you can kind of see I'm going to get a reflection up here, and I'm kind of out of space. So if you notice, there's going to be a little r. There's going to be a hole. Go from the axis to the curve, little r. Okay, little r. There's also going to be a big R. Go from the axis to the curve. There's big R. Okay, let's find big R. Big R is going to go top minus bottom. The top is 1. The bottom is the exponential, e to the negative 3x. If I look at little r, top minus bottom, little r, the top is 1. The bottom is square root of x. Okay, to find the volume, I'm just going to have to go pi times the integral big R squared minus little r squared dx, and we're going to take the same limits, 0.238 to 1. Again, plugging in the calculator. If you work this out, this is approximately equal to 0.453 pi, whatever that is. Okay, so that's the volume of revolution. Part C, which is the last part, says R is the base of the solid. For this solid, each cross-section perpendicular to the x-axis is a rectangle whose height is 5 times the length of its base. Okay, so pretend that the rectangles are going to be coming out of this graph. Okay, so this is going to be our S. Pretend S is here. Okay, what we know about the rectangles is that they have a height that is 5 times their base, so 5s. Okay, so we got to find the volume. So what we're going to do is find the area, which is base times height. So that's going to be s times 5s, so 5s squared. And we will add up all the little rectangles, dx from 0.238 to 1. Calculator says that's about approximately equal to, actually let's find s first. S is top minus bottom. Top is square root of x. Bottom is e to the negative 3x. Okay, so calculator says it's about 1.554.